Okay, here's our Chapter 7 review. The first thing we need to be ready to do for our test is these top two boxes here. Not so worried about the isosceles, trapezoid, or the kite. Not going to ask you those, but we need to know our special things about a parallelogram. Here they are. You know, the opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, and our consecutive angles or supplementary and diagonals bisect each other, okay? Well, a rectangle has two special things we know that about it. And that is that we have four right angles and the diagonals are congruent, okay? So now we have our rhombus. Rhombus has a couple special things about its sides and its diagonals. And that is that all sides are congruent. The diagonals are perpendicular. We got 90 degrees going on here. And we know that they bisect the angles, so these angles are the same. And these angles are congruent. Okay, that's special about a rhombus. So we want to have those down. Make sure you're ready for those on the test, all right? Well, let's continue on here. Again, don't worry too much about those bottom two. Next thing we move on to is we got some angles and a regular hexagon. Remember, for the interior angles, we have n minus 2 times 180. So in this case, n is 6. So it's the number of sides minus 2 times 180. That's our formula. You need to know that. And so this comes out to 4 times 180, which is 720. The exterior total is always going to be 360, okay? That's true for any polygon, all right? So there's our totals. Now the next part of the question says, what if we have one interior angle, all right? How do we find one of them? Well, we know it's a hexagon, and so we got to divide by 6 sides. So we're going to take our interior here, and we're going to divide that by 6, all right? And we get one angle is 120. For the exterior angles, well, we'll take that, and we got 360 divided by 6, which is 60 degrees. So one exterior angle is 60. By the way, these two angles will always be supplementary, one interior and one exterior, okay? Because when we draw this hexagon, okay, we're going to have an interior and exterior, kind of like this. So here is my exterior, and here is my interior, and they'll always be right next to each other, so they'll add to 180. All right, cool. Well, let's look at number 3 here. Okay, we're going to graph this quadrilateral. We're going to find all the slopes and all the lengths. So first, let's graph it. So here is our quadrilateral, all right? Looks like a rhombus, but we need to prove it. So the first thing we're going to do here, we're going to find the slopes and lengths of each side, all right? And we're going to display them clearly. You can do that right on here if you want. So we're going to find the slopes. And so we've got a slope here, and that is going down to the right, so it's negative 1/3. Same thing on the bottom here. And over on the side here, we have m equals negative 3/1. So we're going down 3, right 1. All right, so and now we'll find the lengths of the side using the Pythagorean Theorem. And we'll just use the 3 and 1 here, 3 squared plus 1 squared. Notice that they're all rise of 3 or run of 3 and 1. So they're all combinations of 3 and 1. So we just get simply going to have 10 equals c squared. And so that's going to tell us c is the square root of 10 when we square root both sides. All right, so the length of all the sides is the square root of 10. Okay, so what this is going to tell us is that we know what type of polygon is. We can say that this is a parallelogram. And we have to have a reason for this. We got two reasons now because we said opposite sides are parallel, because the slopes are the same, and opposite sides are congruent. Okay, so it tells us that much are congruent. Also, we showed that all the sides are congruent, so we can say that it's a rhombus. We have two ways of saying it's a parallelogram, and we'll take one. We'll also say it's a rhombus because we showed all sides are congruent. Okay, now also it tells us it's not a rectangle because the slopes are not negative reciprocals. So these are not negative reciprocals, so these aren't perpendicular. Of course, we know they're not perpendicular. We can see that. So it's not a rectangle. So it's not a rectangle, but we know all the shapes. Now, just for a little extra practice, we're going to find the length of the diagonals, the slope and the lengths of the diagonals. So let's go draw these guys in, and we'll find some slope and lengths. We see that our slopes of DB, rise of 2, run of 2, and AC is going down 4 over 4. All right, so we can write some slopes here. We have DB was m equals 2 over 2, which was 1. And for the other one, AC gave us a slope of negative 4 over 4, which is negative 1. Now, what that shows us is that means we have, those are negative reciprocals, even though they're not fractions. You can think of them as 1 over 1 and negative 1 over 1. That's interesting. And so these are perpendicular bisectors, and so we have perpendicular diagonals. They are perpendicular bisectors, but let's call those perpendicular diagonals. All right, and so that means that it's a rhombus. Okay, so that's another way to prove that it's a rhombus. So it's a rhombus. Woohoo! Okay, we already knew that, but these are options. You don't have to do all these on the test, but you need to be ready to use these different tools, okay? If we want to find the length of them, we can use these 2 and 2, 4 and 4 to find the lengths. I'll do that real quickly here using some Pythagorean Theorem. So using the 2 and the 2 from the rise and the run there, we got 8 and the square root of 8. So let's try this one with 4 and 4. And we end up with, oh wait, that's wrong. Let's back that up. Should be 16 plus 16. This is going to come out to be 32. And so is the square root of 32. All right, so moral of the story, these are not the same. And since they're not the same, this guy right here and this guy right here, oh, that doesn't do very well. Not the same. So it's not a rectangle, okay? And again, we kind of already knew that, all right? So now, last but not least, we just say, what does this prove? It proves it's a rhombus, but not a rectangle or a square. So it's not a rectangle because diagonals are not congruent. Okay? All right. So that's the idea. Okay? Diagonal is not congruent. All right, it's a rhombus, but it's not a rectangle. Well, hey, again, that's more than you would need to do, but those are all the different ways to prove what a shape is. Okay, what a polygon is. So we come to the next page here, and we're going to do the same thing. We're going to graph this thing and see what we get. Here's our rectangle. It's kind of glowing, I guess. So we're going to find some slopes and lengths of the sides. Let's do that real quick here. So we got the short lines there, a slope of negative 2 over 1, which is negative 2, but that's good enough. The longer lines has slope of 1/2. This is rise of 2, run of 4, which simplifies to 1/2, or 1/2, 1/2. Okay, so we got our slopes. Now we got to find our lengths. So let's go ahead and find the lengths of the sides. We have two sides to find the length of. Okay, the shorter side, we'll use the Pythagorean Theorem. And let's find a different pen here. So the short sides looks like this. And that comes out to be 5 equals c squared. So c equals the square root of 5. Now the longer sides here, we're going up 2 over 4. All right, so 2, 4. We got to use that for our Pythagorean theorem. All right, so we're going to do the longer sides like this. Call that long. We'll do it with 2 and 4. And 2 squared plus 4 squared gives us 20. We square root. And so c is the square root of 20. All right? So there you go. Now, opposite sides are congruent because we got the same rise and run, or same overall rise and run. So there you have it. Okay? So this shows us it's a parallelogram because opposite sides are congruent. And the fact that the slopes are negative reciprocals. These are negative reciprocals here. We've got negative 2 over 1 and 1 over 2. They're flipped and they're opposite. That means these sides are perpendicular, so we can say this is a rectangle because we showed this. If you don't show this, you can't just say that's 90 degrees. You got to show the slopes are negative reciprocals. So we can say it's a parallelogram because opposite sides are congruent, and parallel, we can say it's a rectangle because they're negative reciprocals. Okay, so it's a parallelogram because we got congruent sides and parallel sides. And we can also say it's a rectangle because we have perpendicular sides. Okay, PPD means perpendicular. Okay, and a little reminder, that is because we have opposite reciprocal slopes. Okay, or negative reciprocal slopes. Okay, cool. All right, so we know it's parallelogram, we know it's rectangle. Let's check the diagonals out here. So we'll go back over here. We'll find the length of the diagonals and see what that tells us. Okay, our diagonals look something like this. Whoa, where are you going? Okay, no green ones. Now, this horizontal one we can just count. So we got BD is just count it. 1, 2, 3, 4, 5. Okay, but this one right here, we've got to use our rise and our run. So notice for this green line, we're going up 4 over 3. So we've got to use the Pythagorean theorem to get this length. It's going to be 4 squared plus 3 squared. So AC is going to give us, let's do our Pythagorean theorem, 4 squared plus 3 squared equals c squared. Okay, so this comes out to be 25. We get 16 and 9, that's 25. And so when we square root, we get 5. So what do you know? AC is 5. So the diagonals are congruent. That's awesome. And so that means that they're rectangles. Okay, oh, and the slopes, let's talk slopes. We have slopes are 0, and this had a slope of 4/3. That's where these 4 and the 3 came from. Okay, so let's see what we can do with that. So BD, let's go here. BD, we said was 5, and the slope was 0 for BD. And for the other one, AC, its length was 5, but the slope was 4/3. Okay, so what does that tell us? First of all, the diagonals are congruent, so that means it has to be a rectangle. Okay, so it's a rectangle. Okay, because diagonals are congruent. Again, we just found the same answer 2 different ways. You're going to need to do one of these on the test, okay? We also found out that it's not a square. No, wait. Yeah, it's not a rhombus because the diagonals are not perpendicular, okay? So it's not a rhombus. Okay, not a rhombus because the diagonals are not perpendicular. If they were perpendicular, those would be opposite reciprocals. Okay, since it's not a rhombus, it's also not a square. It's got to be a rhombus first to be a square. Okay. Okay, and we can also say it's not a square because the sides are not congruent. We found the sides up here. The sides were square root of 20 and square root of 5 and so on. All right, so now those are a big part of the test there as we've been talking about, all right? A couple more. These are fairly quick ones, okay? So we've got a parallelogram here. If AD is 6x minus 4 and BC is 56, well, those two have to be the same because we know opposite sides are congruent. So let's make an equation. And that should be pretty easy to solve. Add 4, add 4. 6x equals 60 divided by 6. And x is 10. Okay? Got it. All right? Opposite sides are congruent if it's a parallelogram. Okay? If we've got some rectangle here, okay? If it helps draw it out, LMJK, LJ is a diagonal, and MK is a diagonal, okay? So let me try drawing this out here. LMJK, LMJK, all right? And our diagonals look like this. Okay. Okay, so there's our diagonals there. Okay, and so what do we know about the diagonals of a rectangle? They are congruent. Got that one down? Okay, so they're congruent, they're equal to each other, and so we can set our equation up. Now we can solve it. Let's get 3 out of there, and maybe while we're at it, let's get 5x out of both sides. Okay, so 2x equals 7 minus 3, which is 2. No, sorry, it's 4. And we'll divide by 2, and that tells us that x is 2. Okay, and the directions just asked us to find x, so we're good to go there. Didn't ask us to find the lengths. Okay, double check, make sure. If it asks us to find the lengths of the diagonals, we'd have to plug this back in. All right. Cruising along here, number 7, we assume this is a parallelogram, all right? So, and we know that angle D is 43. Anytime you have some information that's given to you, then it's always good to write it in. So let's write this in. We got 43 degrees, okay? So we want to find the missing angle. Well, if that's 43, we know that these consecutive angles, that one and these two together, add up to 180. So 43 plus, let's say, x equals 180. And subtract 43, and we get x equals 137 degrees. Okay, so x, what is x? Well, I'm calling x this whole angle. Okay, and 95 is part of it, so how about we do 137 minus 95, and that's going to give us 37 plus 5, which is 42 degrees. So this guy's got to be 42 degrees. Okay, there's our solution. Okay, there's the missing angle. All right. Okay, so cruising along, number 8 here, we've got a parallelogram. Okay, the diagonals intersect at point M. Again, a drawing might be helpful here. So let's draw it up. Something like this. It's just a parallelogram, nothing special about it. Y, V, W, X, going around in order that way. Okay, and we've got 2 diagonals. Okay, and so something like this. And this, got the cool shadow still going. They intersect at M, it says, midpoint M. Okay, and so we're told that WM is 32. So if this guy here is 32, find the length of the whole diagonal. Well, if that's 32, this guy's got to be 32 over here. So the whole diagonal, YW, has to be 2 times 32, which is 64. Okay, so that's the idea. All right. Okay, in this rhombus over here on the right, we know BDC is 42. Write that in. Okay, the question is, we also know DE is 8. And we know EC is 6. We want to find all the missing sides and lengths. So we know some special things about a rhombus. We know that we got 90 degrees in the middle. Okay. Since that's 90 degrees, we also know the diagonals bisect each other. Have nothing to do with 90 degrees there. Okay, so these two parts will be 8 and 6 like their other halves. And then we know that the diagonals bisect the angles. So this will be 42. Using alternate interior angles, this one here and this one here are alternate interior angles. So this guy's got to be 42 also. Now, these two angles have to add up to 90. So if I take 90 minus 42, we get 48. So this guy has to be 48. And so do both of these. And alternate interior angles tells us these have to be 48 also. All right, now, last but not least, we don't know these sides here, the outsides, but we have a right triangle. See that right triangle going on there? Okay, so this whole business here, this whole triangle is a right triangle. So we want to use that right triangle. In fact, they're all the same, right? There you go, nice scribbly right triangle. Okay, so they have sides of 6 and 8, so we can say 6 squared plus 8 squared equals c squared. C is the length of this side. And so 6 squared is 36 and 64, and that's 100. And if we square root both sides, we get 10. So this is 10. And so all the sides are 10 because it's a rhombus. All right. And last one, we got a trapezoid. We know that we got two cases here. First case is saying that AB is 6 and CD is 14. Find PQ. Well, we know these guys average. So that's the mid segment. PQ is the mid segment. Notice these are the bisectors, okay? So 6 plus 14 divided by 2, we average it, and that's going to give us 10. Okay? Now, if we reverse this, we'll get our last one here. Okay, so change it up, mix it up. Now we know that AB is 9, PQ is 12. Well, what's this one? Well, since PQ is the midpoint, or the mid-segment's the average, so this is going up 3. This guy's going to have to go up 3 also. And so X is going to be 15. Okay? All right. You could also make a nice equation for it, but that's the easiest way to go. It's the middle, it's the average, so well, that's good there. All right. So there you have it. Okay, that kind of covers just about everything to be ready for the test. Remember, on the front page, you want to get your formulas for the total angles, n minus 2 times 180, and exterior angles 360. Okay, and all of your the chart on the first page there. Get that thing memorized. Okay, all right. Study hard.